This tutorial is about track correction in the Baxter algorithms. Here I have selected 3 image sequences where I'm going to show track correction, and these are the same image sequences that I tracked in 3 other tutorials. So this is transmission microscopy, 2D fluorescence microscopy, and 3D fluorescence microscopy. I select manual track correction. To open the manual correction user interface, it's the same user interface that we use for visualization of tracks. And I'll open the tracking results we generated using classifiers, and then I get this user interface. The menus here give you a lot of different options, and then there are some correction tools and visualization tools here to the right. The first export menu lets you export images and image sequences. If I go to the last image, I can export both the lineage tree and the tracking results. Pressing this button, I'll just save it to the desktop. Then I got this image, and I could also save sequences of images like this. And then I can select what image channels I want to show. In this case I only have one, and I can select the plotting style. The save style is a little bit different. All of the center points have the same appearance, and the outlines are a little bit thicker. This is usually nicer looking if you record a video. And this ISBI option marks the current time point as a circle, so that it doesn't cover small cells. So this is mostly useful if you're tracking particles or small cells. And then there are 3 different coloring options. The rainbow option will color the lineage tree from red to yellow, green, blue, and back to red. If you select random hues, the cells will be given random hues, but the saturation and the value, or saturation and intensity, are both maximum. This can be useful if you're tracking sequences with many cells, because then the daughter cells in a cell division have different colors, or will usually have different colors, and that can make it easier to link the tracks. And then there's random colors, and in this case the cells are given random colors from a set of fixed colors. In this case the daughter cells will never be given the same color. And then you can select whether or not you want to show the lineage tree. You can also select that you want it in a separate window, and you can select that you want to show the time axis in hours instead of frames. This drop-down menu gives options for cell segmentation editing or outline editing, and I'm going to make a dedicated tutorial on that topic, so I'm not going to go through them now. On this top drop-down menu, you can select what tracking versions you want to open, and then these display toggles or display tools specify how you want to display the tracks. This first toggle button toggles the plotting of trajectories or tracks on and off, and the text box next to it specifies how many time points back in time we should plot the tracks. In this case it's 3, but we could also do 10, or we can specify infinity, inf, which means that all of the prior time points are plotted. There's actually a shortcut, so while you're editing you can press the number keys to select how many time points you want to plot. So if I press 0 I get none, if I press 9 I get 9, and so forth. The next toggle button toggles the plotting of outlines on and off. You can also select if you want to plot multiple outlines. So in this case I will plot the outline in the current image and in the previous image. And this is convenient if you want to see how much the morphology has changed over time or something like that. These white regions here are false positive objects or false positive tracks, which were detected by the segmentation algorithm but not included in any cell tracks. These regions have been linked to nearby regions, so it's easy to get these tracks back if the track linking algorithm missed a true cell track and made it a false positive track. And if we had just deleted these objects, it would take a lot of time to draw outlines manually for all of the frames that were missed. You can, however, toggle the display of these false positive objects on and off, and you can also select the color for the false positive objects. This is an RGB triplet with values between 0 and 1. So 111 means that we have maximum intensity of all three colors. If we set it to 000, we have no intensity in any of the colors and we get black. We get red by setting the first element to 1. If we set the second element to 1, we will get a mixture between red and green, and that's yellow. But usually you will go for either black or white, depending on what is most visible with the given background. If we plot the full tracks, we see that we have, I can turn the false positives off, that we have cell division events marked with circles and cell death events marked with X's. If you press this toggle button, you toggle the plotting of such events on and off. And then this toggle button just turns the display of this horizontal line in the lineage tree on and off. That can be useful if you want to save a picture of the lineage tree. And then we've got some visualization tools. This magnifying glass just turns the zoom tool on and off. In all other players this tool is on by default, but in the track correction interface you need to turn it on. And then this selection tool allows you to identify tracks between the image and the lineage tree. So if I want to know which cell is which, I can click on the cell in the image, and then the cell is highlighted in orange, both in the image and in the lineage tree. And I can also click on a cell in the lineage tree and highlight it in the image like this. This is useful mostly if you have a lot of cells, so that the colors are not enough to identify the cells. And then if you want to permanently color the cells, so this is just a temporary coloring, you can use these coloring tools. this tool will color all of the cells in the same color. In this case we have 1 on the green channel, so this is gonna color all of the cells green. If I press this button, click OK, all of the cells become green. And then I can choose to color a single cell in a different color using this tool. So I select the tool and specify a color that I want to color the cell in. In this case it's red, so I'll just click on this cell, and then I've colored the first generation of the lineage tree red. Now if I want to color the second generation blue, for example, I can enter blue here, 001, and then I click on the cells. The cells become blue. And now I can make the 4th generation yellow. So this can be useful if you want to highlight something in a figure for a paper or something. And then if I want to go back to the normal coloring, I just use the coloring menu. Now we only have the track correction tools left. I will first explain the tools one by one and show how they affect tracks. And then I will correct all of the tracking mistakes that were made in this video. So this first tool allows you to change track links. So you click on the center point of a cell in the previous image. It's the filled circle here, or the small dot. And then I click on the center point of a cell in the current image that I want to link it to. And that's the large filled circle here. And then I can do the same thing with this cell and link it to the beginning of this new track here. If I want to correct the tracking mistake I just introduced, I click on this center point and then on this center point, and the same thing here. Now I'm back where I started. This tool allows you to move cells in the current image. So if I turn false positives on, I can move this center point into the background, then this region becomes a false positive region, and this is a point object in the current frame. I can also move it into one of the other regions, and then the region is split between these two tracks. I'll just move it back into the region it came from, and then that region becomes a normal region again. The next tool allows you to add point objects to the current frame. So if I click in the background, it becomes a point object, and if I click inside some other region, the region will be split. This tool allows you to create a chain of such objects, or a track of such objects. So you click on a center point in the previous image, then you get a partial link with a dot in the end, and then you can click somewhere in the image and the program generates a point object or an object inside an outline where you clicked, and then it moves to the next frame so that you can create more of these objects. And in this way you can generate a sequence of objects either in the background as point objects or inside other regions. When you select a different tool, the tracking ends. So the next tool allows you to copy cells. So if I click on this cell, or copy or split, now apparently I clicked twice here, so I copied it twice. And when you copy a cell, the copies will stay in the same regions as the cell that you clicked on, and the region will be split between all of the tracks inside the outline. So I can do the same thing here, but only click once, and then I've duplicated the cell. The next tool lets you do the same thing, but you click on a center point in the previous image, and then you click on a cell that you want to copy, and then the cell that you click on will be copied from the current frame onward and linked to the partial track that you just created. So if I click here, then I link it, and I also keep the cell that I clicked on. You show it again here. And here we see that some of the links changed, and that's because we clicked inside regions, so that they had to be updated using a new segmentation. And when a new segmentation is computed, the ingoing links and the outgoing links of the new regions are relinked. This will normally save a lot of editing. I was going to show you the track split tool again. So I click on one region on the center point of the previous image, and then I click on the region that I want to copy, or the cell that I want to duplicate. It's duplicated from the current frame onward. And then we have the, I think I'll actually reload the tracking results because I've created so much garbage here. So the next tool lets you specify daughter cells. So if I click on this cell, I generate a mother cell, and then I click on the two cells that I want to be daughter cells. I'll take this one and this one. So now I've introduced a new mitotic event here. The next tool does the same thing, but instead of, I think I'll move a few frames forward so that you don't become confused. So the same, or the next tool first creates the mother cell by clicking on the center point of the previous image, and then I click on the two daughter cells, and then the cells that I click on will be copied from the current frame onward. So I duplicate cells, and the copies become daughter cells of the mother cell that I just clicked on. So here I've duplicated that cell, and then I'll duplicate that cell. And this tool is useful because oftentimes when you miss a cell division, you also get a cluster of two cells. So then you duplicate the cell which represents the cluster, and then you introduce the daughter cell inside that cluster. If we look at these tracks, they end with an X, and that means that they undergo apoptosis. If you want them to not go through apoptosis, if you want them to leave the image either through migration or by being washed out of the image or something like that, you use this tool, and then you click on the cell, and then the X is removed, and the cell is assumed to leave the image in some other way. either through migration or through some other mechanism. I can do the same thing here. The apoptotic event is removed, and if I change my mind and want to introduce mitotic event again, I just click on the same cell using this tool again, and then apoptotic event is created. The next tool is used to change the time point when a cell divides. So here is a cell division, or maybe I'll use this cell division to show it. So this one seems to be at the right point in time, but if I wanted it to occur earlier, here for example, I click on it here, and then I move the mitotic event to this frame. I can also change it so that it occurs later. If I want it to occur here, I click on one of the daughter cells, and then I move the mitotic event. The next tool is used to delete tracks. If I left click on a track, that track and all of the daughter cells in the lineage tree are removed, and they're removed from the current frame onward. If you instead want to delete an entire track from the beginning to the end, you right click on that track, and then the entire track is removed from the lineage tree. If you change your mind and you want to undelete something, it's done with the same tool. You can undelete it either from the current frame onward, or you can undelete the entire track by right clicking. So there I right clicked and I got the track back. You don't get mother-daughter cell links back. You get the subsequent mother-daughter links, but you don't get the link that you had before you deleted the cell. This next tool is for segmentation editing, and that's something you can use if you want to change the morphology of a cell. I'm gonna make a dedicated tutorial about this, so I'm only gonna go through it briefly. Here we can see that the outline of this cell is not correct, so we can use this tool to change it. And it's just a paintbrush where you either paint more cell or you erase cell. If you left click, you paint more cell. So I'm painting this Philopodia here. And I can paint the outline of this Lamillipodia as well. Usually segmentation editing is not necessary, but if you get something which is off by a lot, if you get a huge bubble or something which is segmented as a cell, you may need to do it. Or if you're very interested in detailed morphological analysis, then you may also need to perform the segmentation editing. But usually you don't do this step. You erase by right clicking like this. And the three last tools here, the first of them removes false positive tracks without segments. So if you have point objects which are considered false positives, you remove them by pressing this button. Now this will be removed. Oh, this probably has an outline. Yes, it did have an outline, but if I create a new cell here and delete it, then it can be removed by pressing this button like that. And then the jump tool will move to the next frame where the number of cells changes, and that can be useful if you have only a few cells like this. If I press this button, I go to this cell division event. If I press it again, I move to that, and so forth. And then this save button is used to save your tracking results, but I won't save them now. Now I'll just reload the tracks so that we can correct the actual tracking mistakes in them. Don't want to save these. And you can't use the magnifying. You can use the magnifying glass to zoom into the lineage tree, but if you have it selected, you can't move between frames by clicking in the lineage tree. We'll just watch this and see where tracking mistakes occur. I actually know that there aren't any tracking mistakes until about here, where a cell divides. Now it divided, but the algorithm didn't catch this cell division because it doesn't look like a normal cell division. We have this extension on the cells. It wasn't recognized by the classifiers. So to correct this mistake, I can use the move mitosis tool, and I click on the cell, and now I've introduced the mitotic event that was missing. Now we can see what happens to the two daughter cells. Well, it looks correct. I don't see any more tracking mistakes here. Now I'll just save the corrected results here. And I normally just add corrected to the end of the tracking result label. Now the results have been saved, and we'll move to the next image sequence, because this has more mistakes that we can correct. We'll start in the first image. This looks fine. We can lower the frame rate and watch the sequence. Now we have something here which should have been classified as a cell, but it wasn't. So I'll use the delete tool to get it back. And here the cell moved too far for the algorithm to catch it. So we need to introduce this link using the track linking tool. There was a new cell that I came from there, so I'll undelete it here. And now I can use the track split tool to move this cell, which was lost, into this cluster. So now the cluster is split. It splits in all of the following frames. So I need to relink it like this and delete the track that I just created, because it's going to follow this yellow cell to the end of the sequence, and we don't want that. once you start getting a lot of tracking mistakes, it's easier to move using either these buttons or using the arrow keys on your keyboard. But I'll use the clicking option just to show you what I'm doing. So here a cell, the cell moved out of the image according to the track linking, but it's still here. So I'll use the track split tool to edit the tracks and correct them. Now if we care about the cell morphology, we should probably separate these two cells using the segmentation editing tool. But that depends on what you want to do with the tracking results. If you're only interested in the number of cells, for example, you don't need to make a correction like that. I'll move these cells because they were assigned to this small fragment and they shouldn't have been. Here this blue cell should have been here and not there, so I'll move that one as well. It should actually have been assigned to this cluster instead of that cluster, so I use the track split tool to move it to there, and then I'll delete this track in the future frames. And now this cyan colored cell moved out to the image, but it's still here, so I'll use the delete tool to correct the tracking mistake. And here is also a track that should have been, this track should have been continued. And we don't have an apoptotic event, so we should mark the cells as having left the sequence. And that's true for this cell and these two other cells as well. Now this blue cell moved to the wrong segment, and I can just correct that by clicking on it and relinking it using the track tool. Right, then I delete the end of that track. Now we need to continue these two tracks into this false positive region. I'll start by using the track tool, and then I'll use the track split tool to create the other one. And now the link needs to be changed. It was actually there. Then I'll delete the end of that track. And I'll remove the false positives just to clean up a little bit. I'm sure there were more mistakes, but I'll just save these for now. And then we'll go to the 3D data set. And the lineage tree is less useful here, so I'll hide it for now, and I'll show all 3D views, because there you can catch more of the track linking mistakes. Also go back to the first image. So here we've got two cells too many. I'll just delete these to start with, and this cell should have been two cells instead of one, so I'll just use the copy tool to fix that. And this cell here is actually a cell and it's not debris, so I'll use the delete tool to get it back. And this small fragment here is not a cell, so I'll right click on it to remove it permanently. Or it's not permanently removed, you can get it back if you want to. And I don't see anything more here. I think this cell is probably, yeah, this cell shouldn't have been there, so I'll delete that one as well. Here is a cell which, now this is actually a cell, so I'll left click on it using the delete tool to get it back from this cell or from this frame onward. So it's not in the first image, but it will be in all subsequent images. And I think that this track linking here, this orange cell should have gone to this fragment and not there. So I'll delete it in the following images. Here is a track which was lost, and instead this became one single region. So I'll use the track split tool to fix that. I click on the center point in the previous image and then on the center point in the current image of the cell that I want to copy or split. And then I fix that track linking result. And here is another mistake. Now the cell shouldn't share outline with that cell anymore. It should be linked to this, so I'll relink it and delete the end of the track. And here we can see something where a cell moved from here down to there. So I'll zoom in all of the views to see what actually happened. And this track here should have been linked to there. So I'll click on it in this view, and you can actually go to the other views and create the link there. In this case it wasn't necessary, but sometimes it's easier to do in a different view. And then I think that this cell here should have been linked to that cell instead, and this one should be removed. And then I can go back in the zoom by double clicking, and I only go back in one view if I double click in it, so I need to double click in all views to, or in two views to zoom out fully. Here's another link that had to be made. I think this will take a little while to create, and I think you've seen most of the techniques now. I think that I will end the tutorial here. One thing to remember is that you may not have to perform correction to get the results you need. Depending on the output that you're interested in, you may not need to correct at all. If you're only interested in the cell count, for example, you may not need to do any corrections. But if you're interested in the lineage tree, you will have to correct all of the track linking mistakes. If you're interested in detailed morphological analysis, then you need to perform segmentation editing in some cases. So don't do more corrections than you have to.